So hello everybody, and so this is my presentation, my poster presentation of a spanning set. So what a span, well, the definition of the span is that it is a collection of vectors from which any vector in the space can be formed through linear combinations, which I'll go over in a bit, but first I'll explain like why it's important. So first off, spans are essential to learn in linear algebra. It's essential to learn early on throughout beginning to learn linear algebra, and I'll also go over that a little bit too. It also helps us understand the space vectors that are these vectors are in. So it's also key to understand that it helps define vectors and their structures. And what I mean by it's easy or helpful to learn early on is that I've included an example such as these matrices, and that I've included how to add just for as a refresher, because although they aren't a span, they do help us understand spans. And then I've also included, say, like A times B, and how one would go about, multiplying two matrices together, because that also helps us understand the concept of spans later. And so another piece of useful information I also learned is that multiple matrices can also create a span, and that I've had to have something short as a visual representation of what a span looks like. Is this? Is that, say, our span R2, or it requires two vectors, and that these vectors are the elements of the span, and that it requires, say, two dimensions, and we have the standard basis for the span, and that it requires, so we have the dimension here, and that this is pretty much the notation, set builder notation, and then we have the standard basis. And then these could also be expanded, in that we can expand it even further, and it could pretty much be expanded continuously. So I've set the other example here, and that it continues to grow much further throughout, as this is starting to become the beginning of the definition was that it was a span of collection of vectors within the space, and that they can be formed through the linear combinations. So this is showing you that these are linearly dependent spans. And then I've included it to even go much further, and it can be expanded multiple times up to whatever amount required. And I've had an example here, so as we can see that this is also determining whether this vector an element of this span, and we're here to check. So basically we have this to check, and so we have to multiply these two together, which is why I also had these as an example, because we do have to learn how we use multiplication and how we use it accordingly to the spans. And that's basically my poster.